When solving an absolute value equation algebraically, we need to consider two cases. The first case would be if our answer inside our absolute value is a positive and then would stay positive. And then the second case is if the absolute value turns out to be a negative, which would then turn positive. So case 1 is going to be the positive case, and case 2 is going to be the negative case. So when I calculate case 1, what I do is I leave the function as it is. I just get rid of the absolute value. So I get x minus 2 equals 7. To solve for this, I'm going to add 2 to both sides, and I get x equals 9. Now substituting this back into my equation, 9 minus 2 equals 7. So case 1 is true, so that is actually an answer. For case 2, what I need to do is I need to figure out what would happen if this was a negative value. So I'm going to make it a negative. So by doing that, I'm going to go negative x plus 2. So I changed both signs in my absolute value, and I'm going to find out what makes that 7. I'm going to minus 2 from both sides, which gives me negative x equals 5, which in turn gives me x equals negative 5. If I substitute that back into the equation, negative 5 minus 2 is going to give me negative 7, and when I take the absolute value of that, I get positive 7, so that's also a solution. Sometimes I can get extraneous values here. In this one, for my case 1, I'm going to solve it exactly as it is. So I solve 2x minus 5 equals 5 minus 3x. I'm going to add 3x to both sides to get the x's together, which gives me 5x minus 5 equals 5. Add 5 to both sides, I get 5x equals 10, which gives me x equals 2. When I substitute 2 back in here, I get the absolute value of 2 times 2 minus 5 equals 5 minus 3 times 2. So inside here, I get the absolute value of negative 1 equals 5 minus 6 is negative 1. Well, the absolute value of negative 1 is positive 1, not negative 1. So this answer here is extraneous. For case 2, I'm going to change it to its opposite. So I get negative 2x plus 5 equals 5 minus 3x. So I'm going to add 3x again to both sides, and I get x plus 5 equals 5. When I subtract 5 from both sides, I get x equals 0. If I substitute 0 into my original equation, what I get, 0 minus negative 5 is the absolute value of negative 5. 5 minus 0 is just 5. Well, the absolute value of negative 5 is 5, so 0 is a solution to this equation. Sometimes I can figure out that whether there's a solution or not without even graphing it. In this case, if I subtract this 9, I will end up with the absolute value of 4x minus 5 equals negative 7. An absolute value cannot equal a negative number because by definition it's the positive answer. So this answer here, as soon as we figured out that we've got an absolute value equal to a negative, we know we've got no solution. We don't need to solve anything because none of our solutions are going to work because you can't have an absolute value equal to a negative number. So this question is very quick to do because we can see after the first step that it's going to be impossible. If you did solve it using case 1 and case 2, you would get solutions, but then you would find when you substituted them back in that they would both be extraneous and you would actually have no solution to this equation. When looking at a quadratic, the concept is exactly the same. So we've got case 1, we're going to use our regular function, x squared minus 9 equals 0. I could solve this by factoring if I wanted to. X minus 3, x plus 3 equals 0. I get x equals 3. And negative 3. When I substitute that back into the equation, both answers work. Both answers will give me 0. So 3 and negative 3 are both solutions in this case. In case 2, I'm going to switch the signs. So I get negative x squared plus 9 equals 0. If I wanted to rewrite this, I could write this as 9 minus x squared equals 0, and then I could factor the difference of squares. 3 minus x and 3 plus x. And in this case, I get x equals 3 and x equals -3. So it turns out in this example, I get the exact same solutions as I already had. So those are going to be my only solutions, x equals 3 and x equals -3. In my final question, I'm going to solve this one algebraically. So the best way to solve quadratic equations is to make them equal to 0 and then try to factor. So I have -7x plus 1 equals 3. I'm going to have to make that equal to 0, so I'm going to take away 3 from both sides. I get 2x squared minus 7x minus 2 equals 0. I can see that I would need a number to multiply to give me 4 and add to give me, or -4 and add to give me -7. No such number exists, so I'm going to have to use the quadratic formula in order to solve this. So I've got -b plus or minus the square root of b squared minus 4ac over 2a, which is going to give me -7 plus or minus the square root of -7 squared minus 4 times 2 times -2 all over 2 times 2. Simplifying this a bit more, I get 7 plus or minus square root of 65 all over 4, which is 3.8 -0.3. If I substitute those back into my original equation, it actually turns out that they both work. Now case 2, I have to do the same thing, but I'm going to switch all my signs only inside my absolute value. When you're switching the signs for your cases, you're only concerned about the signs inside the absolute value being multiplied by -1. So I've got -2x squared plus 7x minus 1 equals 3. I'm going to take away 3 from both sides. I get -2x squared plus 7x minus 4 equals 0. I don't want to have a negative out in front of here to see if I can factor it, so I'm going to change all my signs. So now I'm looking for something to multiply to +8 and add to -7. Again, there's no such answer. It's not going to work. So I'm going to have to substitute this one into the quadratic formula as well. So I get -7 plus or minus the square root of -7 squared minus 4 times 2 times 4 all over 2 times 2, which is going to give me +7 plus or minus the square root of 33 over 4, which is going to give me 3.1 and 0.3. And it turns out these both work as well. I could check this graphically. If I look at my original equation, once I've got my solutions, if I want to make sure that they actually work, especially since these ones using the quadratic formula can get quite ugly, one of the things I could do is I could use my graphing calculator and I could put in the absolute value equation here. So to get absolute value, you're using the ABS. I got 2x squared minus 7x plus 1. My other equation is just y equals 3. And when I graph this, you can see very clearly there are 4 places where the graphs are going to cross each other, and they do correspond quite nicely to the values that I've got down here. So that is one way to check all of your work and see if you've got an extraneous value, is to graph the solution and see graphically if you in fact do get 4 answers.